Among the countless stars visible from Earth, few are as recognizable as the brilliant red giant known as Betelgeuse. Located in the constellation Orion, it has attracted human attention for thousands of years. Ancient cultures incorporated it into myths and legends, sailors used it as a celestial reference point, and generations of skywatchers admired its distinctive reddish glow. At first glance, Betelgeuse appears calm and unchanging. To the naked eye, it is simply another bright star decorating the night sky. But appearances can be deceiving. Beneath that crimson light lies one of the most turbulent and fascinating objects known to astronomy. Betelgeuse is not an ordinary star. It is a red supergiant, a class of stellar giants that represent one of the final stages in the life of a massive star. These stars are enormous beyond everyday comprehension. If Betelgeuse occupied the position of our Sun, its outer atmosphere would stretch far beyond the orbit of Mars and possibly approach the asteroid belt. Entire planetary systems could fit inside its vast volume. Despite its immense size, Betelgeuse is relatively cool compared to hotter blue or white stars. Its lower surface temperature gives it the reddish appearance that makes it stand out in the night sky. Yet this cooler surface hides extraordinary activity occurring deep within the star. For millions of years, nuclear fusion has powered Betelgeuse. In its core, lighter elements have been transformed into heavier ones through immense pressures and temperatures. This process releases enormous amounts of energy, allowing the star to shine with a luminosity tens of thousands of times greater than that of our Sun. But unlike smaller stars, massive stars live fast and die dramatically. As stars like Betelgeuse age, their internal structure becomes increasingly unstable. Different layers of fusion develop within the star, creating a complex arrangement of shells where various elements are formed. Meanwhile, gravity constantly attempts to compress the star inward while fusion pushes outward. This delicate balance does not remain perfectly stable. Massive currents of superheated plasma rise and fall throughout the star's outer layers. These convective motions are so large that a single region can span distances comparable to the entire orbit of Earth around the Sun. Imagine gigantic oceans of glowing gas constantly churning, expanding, and collapsing. That is the reality of Betelgeuse's surface. It is a dynamic environment where change is the norm rather than the exception. For decades, astronomers have known that Betelgeuse varies in brightness. Such variations are expected in red supergiants. However, recent observations have revealed behavior that has attracted intense scientific interest. Beginning in late 2019, observers noticed something unusual. Betelgeuse started fading dramatically. Within a relatively short period, its brightness dropped to a fraction of its normal level. The change was so significant that even amateur astronomers could easily detect it. News of the event spread quickly. Many wondered whether humanity was about to witness one of the most spectacular events in astronomy, a nearby supernova explosion. A supernova occurs when a massive star reaches the end of its life and can no longer support itself against gravity. The core collapses, triggering an enormous explosion capable of briefly outshining entire galaxies. Such explosions create and distribute many of the heavy elements that later become part of planets and living organisms. Because Betelgeuse is considered a supernova candidate, speculation grew rapidly. Had the final countdown begun? Subsequent research suggested a less dramatic explanation. Evidence indicated that the star had likely ejected a large cloud of gas that cooled into dust. This cloud temporarily blocked some of the star's light, causing the apparent dimming. Although the event was not the beginning of a supernova, it revealed just how active and unpredictable Betelgeuse truly is. Since then, astronomers have continued monitoring the star with some of the world's most advanced instruments. Observatories on Earth and in space have recorded fluctuations in brightness, changes in surface activity, and signs of powerful outflows of material. These observations provide a rare opportunity to study a massive star in extraordinary detail. One of the most valuable tools in this effort has been the James Webb Space Telescope. Because Webb observes infrared light, it can detect structures hidden behind clouds of dust that would otherwise obscure the view. This capability allows researchers to examine the environment surrounding Betelgeuse with unprecedented clarity. Infrared observations have revealed complex streams and arcs of material extending away from the star. These structures suggest that Betelgeuse is continuously interacting with its surroundings, shedding matter into space and reshaping the region around it. This process of mass loss is particularly important because it represents a critical stage in the evolution of massive stars. Over time, red supergiants can lose enormous quantities of material. The expelled gas and dust eventually become part of the interstellar medium, contributing raw ingredients for future generations of stars and planets. In this sense, stellar death is also a form of cosmic renewal. The carbon in living organisms, the oxygen we breathe, the calcium in our bones, and the iron in our blood were all forged within stars. Without stellar evolution and supernova explosions, the chemical elements necessary for life would not exist. Betelgeuse serves as a reminder of this profound connection. Although it may appear distant and unrelated to life on Earth, it participates in the same cosmic processes that ultimately made our existence possible. The question that continues to fascinate both scientists and the public is simple: when will Betelgeuse explode? The honest answer is that nobody knows. Astronomers are confident that Betelgeuse is approaching the final stages of its stellar life, but approaching can mean very different things on cosmic timescales. The explosion could occur tens of thousands of years from now, or even much later. Current observations do not provide evidence that a supernova is imminent. Nevertheless, studying Betelgeuse remains incredibly valuable. Every fluctuation in brightness, every cloud of ejected material, and every new observation helps scientists refine models of stellar evolution. By observing a nearby red supergiant in such detail, researchers gain insights into how massive stars behave before they die. These insights may eventually improve our ability to recognize the warning signs that precede supernova explosions elsewhere in the universe. Perhaps the most remarkable aspect of Betelgeuse is how it transforms a seemingly familiar point of light into a source of endless scientific discovery. What appears to be a steady star is actually a colossal, ever-changing engine of nuclear fusion undergoing dramatic internal processes. Its story reminds us that the universe is far more dynamic than it appears. Even objects that humans have observed for thousands of years can still surprise us. As telescopes become more powerful and observations continue, Betelgeuse will remain one of the most closely watched stars in the sky. Whether its final explosion occurs tomorrow or many millennia in the future, the lessons it provides today are already reshaping our understanding of how massive stars live, evolve, and ultimately transform the cosmos. The red giant hanging above us is more than a bright star in Orion. It is a laboratory of stellar physics, a glimpse into the future of massive stars, and a reminder that the universe still holds mysteries waiting to be uncovered.